So there's that. Go back here. All right. So, okay, here's the idea. The instructions for 103 to 112 say, writing a sum using sigma notation in exercises 103 to 112, use sigma notation to write the sum, then using graphing utility to find the sum. So this is what you need to be able to do. Number one, you need to be able to recognize what's staying the same each time. That'll be represented by a constant. You have to represent how many terms there are because you need that to fill out the sigma part. And then you got to look at what's changing and represent that as a variable. So in number 103, okay, in number 103, 1 over 3 times 1 plus 1 over 3 times 2 plus 1 over 3 times 3 plus dot, 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 plus 1 over 3 times 9. So here's my sigma notation. Looks like that. What is staying the same in all of my problems? And there are two things that are staying the same. What's the numerator in all of them? 1. And what common multiplier is found in the denominator of all of them? 3. And then the other part is changing. That is what you represent with a variable, n. Okay, now the first term has what inside parentheses? 1. So that means we're starting at what? 1. The last term has what in parentheses? So that's why we're stopping at 9. Okay? Make sense? Now, if you want to find that sum, and if you need to write this down before tomorrow, make sure you do, because you can't walk up and ask. We can use the graphing calculator to find that sum. All right? And to do that, remember, we hit math and then 0. All right? And we're starting at 1, so x equals 1. Now, if you want to avoid the error message, instead of hitting enter, you can either go up or you can go over. It's up to you. Doesn't matter to me. And we're stopping at 9, right? So that goes there. And then the expression itself is 1 over 3n. Remember, when you have a rational expression, make sure you put the denominator inside parentheses. Otherwise, it will mess it up. And then we hit enter, and it shoots out the decimal approximation, and then you round accordingly. All right? So if you would, please work on number 104, doing the same thing. If you don't want to find the sum, that's fine. All right, those of you at home, we're going to show how you do this in Edulastic, so please make sure you pay attention. Authored by me, sigma notation quiz example, there we go. You know what? I'm going to blow up a bunch of balloons. And every time you're on your phone, I'm going to pop one in class.
Way better than the water balloon. This water got a bunch of them.
Don't worry about me. I'm good. I got 4th period off. I can come in playing. Okay. All right. So we start with our summation notation. You better not make the same mistake tomorrow, because I'll take points off you. I remember everything. Don't you forget that. I am nothing if I'm not vindictive. I can't carry a tune, but I can certainly carry a grudge. All right. What's staying the same in all my numerators? 5. What's staying the same in all my denominators? 1. What's changing is that part of it. 5 over 1 plus n. All right. What is the first value inside my expression? 1. What is the last value? 15. Okay. Now, for those of you in class, if you want to take a moment to think about how you can better yourselves or life, this is for the people at home. When you are entering it, okay, when you are entering it, okay, okay. When you want to enter the sigma notation, you will pick this up. That is where sigma notation is, big operators. All right, big operators, you click it, and then that's the sigma notation. So you click that. You then move this out of the way. On the bottom, you write your expression, n equals 1. On the top, you just write your number, 15. Or Q5. All right, and then here we have, all right, the expression itself, which is 5 over 1 plus n. And then there you go. Okay, everybody good? All right, let's go over a couple other things then, and then you're off to the races. We can draw a little bit. Woo! Back here. There we go. Okay. So, when you go to the top of the next page, I want to look at a couple more. I want to start with number 107. -3 plus 9, -27 plus 81, -243 plus 729. Okay? Again, is the sign switching each time? Yes. When that occurs, all right, you have -1 to the n involved. But this is the small adjustment you have to think about. Is my first term negative or positive? So you don't have to do anything else. You're good. We'll talk about when the first term's positive in a second. Now, this isn't squared. This isn't cubed. It's not linear. Instead, it is exponential. What is the number we're multiplying by each time? 3. So it would be 3 to the n. Now, you can certainly write it separately if you'd like, or you can combine them together, which would be -3 to the n. Completely up to you. Both of them would be correct. All right, when you write it. Now, with these, there's no ellipses. So you can literally count how many terms there are. 1, 2, 3, 4, 5, 6. Correct? So the top number would be 6, and n equals 1 on the bottom. All right? When you look at 108, okay, there's two things you got to worry about. Number one, instead of negative, you start with a what? Positive. So when you do that part of it, okay, when you do that part of it, all right, when you do the -1 inside parentheses, you have to remember to make that either -1 or +1. Either one is considered correct. All right, times 1 over, all right, because all of them have 1 in the numerator, but what's happening in the denominator? Being multiplied by what? 2, so it'd be 2 to the n. Here's your struggle. The first term is 1. If I plugged in 1, this would be 1/2. When that occurs, you again have to do either the -1 or the +1. Either one would be correct. All right. And then the last one I want to talk about is number 112. All right. Again, in number 112, how many terms do we have? 6. The denominator is being multiplied by what each time? 2. So my denominator would be 2 to the n. And it's okay because 2 to the n would be 1, and that's that. Here's the last thing you got to think of. 1 times 2, 1 times 2 times 3, 1 times 2 times 3 times 4, 1 times 2 times 3 times 4 times 5. What does that imply that we talked about in 8.1? Whenever we're multiplying the number by every other number less than including 1. Rhymes with factorial. Factorial. All right, so your final answer would be n factorial over 2 to the n, 6, n equals 1. And then you're done. All right, so if you want at this point, you got about 29 minutes. If you want to get started on the homework, that's fine. I'm going to just do a walkthrough of what you can expect for tomorrow's quiz. If those of you at home are good, I'm good. If you want to stay logged on to see what the quiz is all about, feel free to stay logged on. If not, have yourself a great day. I will be after today, both in person and virtually, for anybody looking for extra help. All right, so your quiz tomorrow has 15 problems. Has 15 problems. All right. All right. 1, 2, 3, 4 involve factorials. 4 involve factorials. One of which is algebraic. Yep, you're going.
Is your freshman teaching this class?
No, he's downstairs, same room.
Okay, thank you.
You got it, brother. All right. One of them is algebraic. So, for example, the numerical ones might be 10 factorial over 7 factorial times 3 factorial. And you just have to evaluate that expression. Remember that 10 factorial would be 10 times 9 times 8 times 7 times everything going down. 7 factorial would be 7 times 6 times 5 times ... going down. What's going to happen to everything there and right? What are they going to do to each other? Cancel out. However, you still have 3 factorial, so that'd be 3 times 2 times 1. All right? So when it's numeric, I would go down. When it's algebraic, okay? So let's say we have n plus 3 factorial over n factorial. Instead of going down, I would go up, because I think it's easier to see. So n plus 3 factorial would be n plus 3 times n plus 4 times n plus 5 times n plus 6. All right. Got me? Actually, scratch that. I'm going to go the other way. N plus 3 plus times n plus 2 times n plus 1 times n minus 1 over n times n minus 1 times n minus 2. And so what is the n minus 1, n minus 2, and everything else going to do just as well? Cancel out. And you're left with this expression. And you can write it either like that, or you can write it multiplied together. Okay? So, you have a recursive sequence. Which means you have 5, 12, 19, 26, 33, ... All right? So you have to identify the first term. All right? A to the 1 equals what? 5. And then a to the k equals a to the k minus 1 plus what? What numbers are going up each time? 7. So that's how we define recursive sequences. All right? Make sure you know the difference between recursive and explicit formula. What I mean by that is this: if we have 21, 17, 13, 9, 5, 1. All right. A to the n equals a to the n minus 1. This time, instead of going up, it's going what? Down. How much? 4. That's the recursive. But if it wants explicit, now that's different. A to the n equals 4n. And then you look at your d and compare it to your first term. To go from 4 to 21, do I go up or down? Up. How much? 17. So that's, make sure you know the difference between them. You don't want to answer one correctly and have it in the wrong format. And then if it asks you for the 12th term, what do you plug in for n? 12. All right? There is one problem where you have to find the sum of a series. N equals 1, 8, n squared minus 2n, something like that. And you have to do the sum. Feel free to put it in the graphing calculator, it's fine. All right? Now, we just went through, given a sequence of numbers, write it in sigma notation. Here's the difference. Instead of giving it simplified, they're going to give you the final result. This is what I mean by that. 3, 12, 15, nope, 21, sorry. 3, 12, 21, 30, 39, dot, dot. Excuse me, 93. All right. So you're finding the sum of that sequence. What I would suggest you do is you start with your sigma notation. N equals 1. How much is it going up and down each time? 9, so 9n. But I gotta get from 9 down to 3. How do I get from 9 down to 3? Subtract 6. Here's what you have to do. You have to figure out, when they give you an ellipsis, which term that is. So you have to take whatever you get, 9n minus 6, and set it equal to that final value, which is 93. How do you get rid of the minus 6? Add 6. How do you get rid of multiplication by 9? Divide by 9. That's your 11th term. So that means 11 goes on the top. Or you can just plug in and guess and check. It's up to you. All right? So you got 2 like that. All right? Then you have 4, where you have to define the sequence in terms of n. If it's linear, could be squared, could be cubed, could be exponential. All right? And it could be a factorial. So all those are in place. So you have to identify this. All right? When it's squared, you compare it to the perfect squares. When it's cubed, you compare it to the perfect cubes. When it's exponential, you compare it to, there's a common multiplier. You just have to figure out what number is being multiplied by it each time. And when it's factorial, it's being multiplied by the bigger number each time. So that's what you have to look for. So you got 4 like that. All right? Good? So those are the ones you got to look for. All right. Then we're going to have one. Like these from tonight's homework. 61 through 64. All right. And you can do it 2 ways. So for example, if they want the sum of the first 4 counting numbers, first 40 counting numbers, they want the sum of the first 4 counting numbers. All right. That would be 1, 2, 3, 4, ... all the way up to what? 40. Choice A is using sigma notation. What's my first number? 1. What's my last number? 40. And then N, nothing else. And you can plug it into your calculator. Or you can talk about what we did yesterday, which is the formula a to the 1 plus a to the n times n over 2. What's the first number? 1. What's the last number? 40. And if there's 40 numbers, n is 40, what's 40 divided by 2? 1. Either way will get you the right answer. And then the last problem is they're going to ask you to find something like the 34th partial sum of, I don't know, 8, 18, 28, 38, ... All right. First off, it's going up how much each time? 10. So it'd be 10n. Then I compare d to my first term. How do I get from 10 down to 8? I subtract 2. All right. You can go right to sigma notation. Is that a better sigma notation, John? Okay, I've been working on it. All right, this will be n equals 1. This will be whatever partial sum they're asking for, which is 34. And then you just slide over what you got there. Or, same as the one above it, you can do n over 2, a to the 1 plus a to the n. If they're asking for the 34th partial sum, that means they're looking for 34 numbers. 34 divided by 2 is 17. The first term is what? 8. And then to get the 34th term, you just plug in 34 into this. 34 times 10 is 340. 340 minus 2 is 338. Either way, you'll get the same answer. All right. So that is what we're doing tomorrow, taking that quiz. All right. I'm going to stop recording.